And welcome to the Daily Space Weather Show. I'm your host, Dan, aka Smash-a-Mash, bringing you the in-depth coverage. These are 24-hour videos from SDO. And there is the equatorial view. This new sunspot group has indeed many more umbrae, a lot more than could be seen on yesterday's video, and you have that X-class solar flare there right at the beginning of these 24-hour movies. And we'll show that here in a moment. First, SDO continuum, and some setting sunspots in the west, some decaying sunspots in the south central disk, and a lot of sunspots in the northeast. That is just today, and welcome to the first day of the rest of our lives. Here is colorized magnetogram for January 1st of 2024. And let's take a brief look at what's going on with volcanic activity. There's a great map for you of currently erupting volcanoes. And fun fact, I don't like calling out the list of volcanoes, so I'm just going to scroll the list instead. No more speed reading and trying to pronounce volcanic names. But that's the list of what's erupting, and the flight levels, the sizes of the ash plumes, etc. And of course, making lots of headlines was the 7.5 magnitude quake at Japan, which we will cover here next. There are the past 90 days of earthquake activity. And the largest quake of the past 24 was indeed a 7.5 on Cape Suzu. Yes, Cape Suzu. That is where it occurred. And it does look like it caused quite a bit of damage as we see red pagers lighting up. And incidentally, there were some small tsunamis associated with this, all smaller than 2 feet in height. So at least 4 small tsunamis generated there. Interestingly enough, there was a foreshock associated with this quake as well. So there was a 5.5 just before it. Just before the 7.4 kicked off. And it was only about 4 minutes earlier there. So there's a 5.5 right at the same location. And then that was at 7:06 this morning, and then at 7:10, a 7.5. So not surprisingly, lots of aftershocks happening there. Indonesia also had a 5.4 at 7:52 this morning. And then Japan, lots of quakes. And that is it. Just Japan and Indonesia. That was all of the 5 and greater magnitude quakes in only 2 locations. Next, some more 24-hour videos. Here we've put together the 131 angstroms, difference imagery, and the 171 angstroms. There's a great view of that X5.01 class flare producing sunspot. And there's the full disk view, another 24-hour video for you there. Very nice. And thanks to our new YouTube subscribers, by the way. We're delighted you were able to find the channel. And we remain somewhat surprised. 10.7 centimeter radial flux now at 136 solar flux units. 136 is the radial flux number. There it is in a 1-year chart. Again, it is down here actually. It has not updated yet. 136 is the F107. No major storms in the forecast here, just a little geomagnetic unrest tonight forecasted by NOAA into tomorrow morning. No indication of why. I think for a coronal hole high-speed stream, we might be seeing that miss entirely, folks, as we ain't got no significant signal for a coronal hole high-speed stream. So that's the Space Weather Enthusiast dashboard. And next, let's take a look at Earth's magnetic moment from space. So there's the earthly geospace modeled by the Space Weather Modeling Framework. And we did see a little uptick here in the magnetic field strength and a strong negative BZ component, but it was short-lived. It subsided promptly. So that is, I believe, what you're seeing with these most recent variations here in the magnetosphere. Again, that's the past 4 hours of Earth's magnetic moment from space. Here is the past 4 hours of Earth's magnetic moment from the ground level. Depicting here magnetic flux density as opposed to magnetohydrodynamic pressure, which was depicted in the last imagery. After all, it is diffuse plasma out in space, and magnetic flux density, the field itself, being measured from the ground level. Well, being modeled. KP index currently at 3. It's about to drop down unless something suddenly changes. KP3 is the average of global geomagnetism. And here's what we're talking about. We saw this strong negative BZ with a field of 12 nanotesla and a negative BZ of 11. So that could have produced some geomagnetic unrest had it continued, but it quickly subsided. So still a stronger field there, but not a strong negative BZ component, at least as measured by the ACE. The Discover showing a similar thing here. Although now the BZ swinging back into negative territory again. That top red line. Current conditions are about 11.5 protons per cubic centimeter of the solar wind density. Solar wind velocity here still quite slow. Again, that coronal hole high-speed stream might be about to miss entirely. Solar wind velocity there, as measured by the Discover, only 342 kilometers per second. GOES magnetometers are next. Fairly smooth, and Earth has just moved into a North Pole heliospheric sector. So just recently, Earth would have snapped into those green potential field surface source lines. Keep in mind that data was over an hour old when we created the video, but North Pole magnetism sector right now. Earth has just moved across the sector boundary crossing. We also like to show the line of sight field plot. There it is. Coronal fields in polar fields, I'll say, in red and green for south and north, respectively. Solar B field, the field that goes through the magnet, in blue. Photosphere magnetism in grayscale. And that brings us to coronal holes. So we'll have North Pole coronal holes rotating in here. No real surprise there, as there is a North Pole magnetic sector. And let's take a look at coronal holes from SDO. There's another 24-hour video for you. Anyway, these are south. And these are north. And as our regular viewers would be expecting, seeing an ongoing uptick in coronal holes. You can expect that to continue for over a year, as solar maximum not only features the most sunspots, but also the most coronal holes on the equatorial region. So that's just base statistical probabilities, folks. No magic here. Those are just the facts. And here come some more facts. The sunspot number still quite low here. And by the way, as we get closer and closer to solar maximum, you can expect to see more wild swings of the sunspot number. That is a completely normal thing to see around solar max. So sunspot number here dipped almost down to 50. And now you'll see it rise up a little bit despite the degradation of some sunspots and some sunspots setting in the west. Here's our flare probability monitor and scoreboard. And again, the most likely place to see a large flare is at 3536. Keep in mind there are a few new sunspots to get named around there, to its north and also behind it to its east. So there should be at least 3 named sunspots in that area. Here are sunspots from SDO. There is the 171 angstroms plus continuum. And we'll also show just continuum. So, we've got a sunspot up here, actually. That sunspot, that'll get a name. So, probably about 4 new named sunspot groups up there in the northeast. Besides that, things largely stable there. A little bit of degradation in that south-central sunspot group. And let's move on to flares and energetic particles. So there's the peak of that proton event. That was associated with that X-class solar flare. A great example of relativistic particles, but not a super huge amount. Not likely to have caused any significant polar radio brownouts there. Since then, only M-class intensifications. In fact, the background flux has gone down in the past 24 hours. It's now down to a very low C or a high B class background flux, like a B 9.4 or something like that. So there's some SDO imagery for you. It's actually 3 different wavelengths there. That is 94 angstroms, 335, and 193. So, and that is actually December 31st and January 1st to date. So it's almost a full 48-hour run there. We'll briefly zoom out there so you can see the time and date stamps. There you go. And moving right along to a star chart. So I like to press now. That's what's going on overhead Lehigh Valley. That's skyandtelescope.org's lovely star chart. Saturn and Jupiter there, still occupying the early evening skies. Here's a solar system forecast. There's where things are today. There's where things will be in 1 week. We will have a crescent waning moon. And the astronomy photo of the day is pretty sweet. It's Galaxy NGC 1232, a classical spiral galaxy. Now you might see a lot of blue clusters. Those are open clusters, which are similar to globular clusters, but not shaped like a sphere. So they're still orbiting a center of gravity. Separate from the galactic core, they're orbiting their own centers of gravity. Open clusters there, a lot of them in the spiral arms of NGC 1232. There's the full disk view. Fantastic view of the ecliptic plane there of that very classic, tightly wound spiral galaxy. You can see lots of dust lanes, some normal stars around some areas there. You'll see stars of various different colors, but lots of blue open clusters around the spiral arms. There's a really big, bright blue cluster there full of rowdy, hot, bright, very active blue supergiant type stars. NGC 1232. apod.nasa.gov is where to get the imagery if you want to check it out yourself. Hey, check it out yourself. And here comes CMEs. So first, yesterday's CMEs, and there were indeed some. But so yeah, that's what was going on yesterday. But let's move on to today. And we ain't got no imagery from today, so let's move on to the LASCO C2 and C3. Here's a little closer zoom. And it's been a little bit quieter today than it was yesterday. So let's take a look at our custom videos. There's a 24-hour video. And I've heard some people thinking that there's going to be a Earth-directed component to that CME from the eastern limb yesterday, and I'm not seeing it. I think it's behind the limb. I don't think any aspect of that Coronal mass ejection is headed in Earth's direction, but if you disagree, let us know in the comments. Or if you agree, let us know in the comments. Or if you're indifferent, let us know in the comments. I'm not seeing an earthly directed component there, but hey, there's plenty of room for people to weigh in. Maybe you'll figure out something new. Who knows? There's another 24-hour video for you, and we'll zoom in even closer. Now we've included the 304 angstroms difference imagery. And right at the beginning of that 24-hour video, you've got that X5.01 class solar flare. That brings us to plasma filaments, which often turn into coronal mass ejections. Here's a further zoom in of those awesome wavelengths. That's the 304 angstroms ionized helium running difference imagery of 60-minute running difference, and then the raw extreme ultraviolet imagery of 193 angstroms. DAG. Pretty sweet. Oh, and here's one additional splentacular close-up of no less than 4 new sunspot groups there. So there's one northwest of the Earth, there's one like just due north of the Earth, the Earth scale in the imagery, that is. And then there are like 2 more sunspot groups to the southeast of the Earth scale. And here comes some views of filaments. So first, Cerro Tololo, Chile. And the major filaments here are currently in the east. We've got this great vertical one, and then this one which looks a little more like an eyebrow. Yeah, that's the situation at Cerro Tololo. And before we get to bonus features, the latest from the GOES 16. There is the ionized helium wavelength from the GOES 16 SUVI. Oh, some activity happening there in the southwestern limb. I see a filament erupting. Possibly a little flare happening there. A little too early to tell, but let's get to our bonus feature segment. So first, satellite charging hazards. There are some over India. Yeah, some surface charging there over India could cause some minor communications errors. That's what's going on for charging hazards. Electron flux here kind of low, actually. So are we seeing a coronal hole high-speed stream show up? I don't think so, because we've got very slow solar wind. There's the past year of relativistic electrons from solon.info. There's the forecast. And, well, the forecast came in a lot closer to the observation than we expected. We expected a much lower level. We were expecting a coronal hole high-speed stream to show up. And next we've got the ionosphere. We'll be showing the F layer. See that red F over there? Well, that's the layer. So there are the previous day's data, and nothing particularly remarkable going on in the ionosphere. If you see something we don't, let us know in the comments. There's the anomaly in megahertz from a 30-day median. This data, by the way, is courtesy of Australian Government Bureau Meteorology. Next, the WAM, the whole atmosphere model, the global ionosphere nowcast, showing total electron content and anomaly on the left, maximum usable radio frequency and anomaly on the right. I like it. I've picked it up as coverage. The daily space weather content ends, and meteorology begins right after we cover the latest high-res imagery from Solar Dynamics Observatory. There's the continuum. There is the magnetogram. And here is the close-up of the active portion. There you go. So that is a series of magnetically complex sunspots. There still is a capability of large flare production from those active regions. And it's now time for thing. There's a thing. It's time for the thing. And the thing is meteorology. So we're going to start with, this is sea surface temperature and ocean currents. So there's the full view of the Atlantic. Sea surface temperature is the shading. Ocean currents are the animation. There's the Arctic. Next we'll do the Pacific. The Southern Ocean. And the Indian. Are we still allowed to call it the Indian Ocean? I can't remember. Anyway, here come the regularly scheduled meteorology segments. Surface winds of the east. Jet streams of the east. Jet streams of the central world. And your surface winds. Surface winds of the Americas. And the jet streams. Let's take a brief look at sea ice thickness and volume. And what's going on with the sea ice volume? Well, it's kind of low. One of the lowest levels ever for sea ice volume. That's the extent times the thickness. In other words, calculating in the thickness of the ice. Very, very low amount of ice in terms of the volume of ice. As far as the extent, well, less extent than the 1978 to 2010 average. So here I'll show you where the year ended. That wasn't the one I wanted. The graph. And there you can see well below the 1981 to 2010 average, which would be right there. That would be the median actually right there. So well below that, and higher than all the recent years except for 2021. Or is that 2020? I don't know. I can't tell. I don't care. But that's the current sea extent and thickness. Sea volume, sea ice, etc. Next, clouds and fog over the Americas. As Brazil clouds up yet again following sunset. Seems to happen every night. I may have noticed a pattern developing. Remember, folks, 2 data points does not make a pattern. However, 3 might. We've got a lot more than 3. And by the way, here's a close-up of another low that's making its way into California. So it looked like the moisture had ended, but guess what? There's another wave on the way. It's already starting to arrive near the California-Oregon border. Another wave of moisture is rolling in from the Pacific. The Pacific, a massive conveyor belt of water vapor. This is your mean sea level pressure map. And if you feel like you're under pressure, well, if you're in the U.S., you're probably under pressure because it's almost entirely high pressure. This is all high pressure. And even Hawaii is under high atmospheric pressure. So if you feel like you're under pressure, you literally are. And let's move on to our weather.gov map. So not a lot of warnings for the next 24 hours here. Weather is pretty chill at the moment. Save for the north shore of Alaska, where there is a blizzard warning. Anyway, here comes some forecasts, starting with the GFS 72-hour pressure and precipitation. So some moisture going to spread into California and then down to the southeast, making its way to New Mexico for some snow and probably even some into Texas. That'll be about 4 days out. But here's a 72-hour GFS total accumulated precipitation forecast. No real heavy rains coming. Some precipitation coming to the Gulf states. The heaviest will be around Nolens. Next, the GFS 72-hour accumulated positive snow depth change in inches. And it looks like we're going to get some snow in Lehigh Valley, Pennsylvania. Yes. Yes. Can't help but like snow, despite being a road cyclist. So, yeah, heaviest snow coming to California. Shout out to Smash Staff's mom. She'll be seeing some white flakes. Last but not least, temperature anomaly forecast in degrees Celsius. 72-hour GFS model. We'll also show lightning. Brazil. Seeing lightning kick up once again after dark. Next, real-time lightning map from lightningmaps.org. And it's actually very calm overall here as far as the areas with sensors, at least only 18 strikes a minute. It's a lightning shortage. And by the way, don't forget to press the like button if you enjoy the content. Tell your friends and foes about the channel. Press like, or there will be ramifications, possibly for your soul. Also, visit our links, which you can find below this very video, as we approach 5,000 subscribers. Thanks to our new subscribers on YouTube. Again, don't forget to visit our links. Smashomash.com contains the links. And welcome to the Neo-Renaissance. We'll close out the video with the latest from radar.weather.gov. The U.S. Doppler radar for the full 50 state and for the lower 48. Clouds and fog. And there is water vapor. Looks like clear skies over Mississippi, Alabama, and Georgia. Here's a recap. Vertical motion in the air column. And indeed, there is some snow there in places like Pennsylvania, Maryland, and West Virginia. Clouds and fog, 3.9 micrometer infrared satellite radiation. And water vapor. It shows you the dry air, it shows you the moist air, and everything in between. And here's me being in between ending this video and right now. So we'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. And by the way, until I'm gone, don't pole vault the caldera. Whoa!